All right, and then the interest rate is the R. So here's your interest rate. So that's going to be in the form of a percent, which you should convert to a decimal. All right, so you want that to be in decimal form. And then T represents the amount of time that you borrow or you invest the money for. And that will always be in years. So that's going to be in years. So let's write that years. All right. So it says here that the time and the interest must be in the same units. Okay. So let's look at some examples. The most common type of simple interest is called ordinary interest. For computing ordinary interest, each month has 30 days and each year has 12 months or 360 days in a year. On the due date of a simple interest note, the borrower must repay the principal plus the interest. So after the due date, you have to pay the original amount that you borrowed, plus you have to pay the interest. All right, so here is an example. The rate is an annual rate, and assume that there's 360 days in a year. So that's going to be what we assume. So let's go ahead and plug in these values to see, because they want us to find the interest. So let's find it by using IPERT. So the principal amount that you're borrowing is $310. The interest rate, anybody know how to convert 4% into a decimal?
It's going to be 0.04.
Yeah, 0.04, because you divide by 100, or you can just move the decimal 2 spaces to the left. So the decimal is here, and then you'd go 1, 2, which means there's a 0 after the decimal. All right, and then there's 2 years, so that would be a 2. And now you can use your calculators to figure out how much interest there is. So 310 times 0.04 times 2 is $24.08, which means 80, right? Because you need 2 decimal to represent a dollar amount, or the cents. So it's going to be, the interest is going to be a total of $24.80. So at 4% interest, if you were to borrow $310 from maybe the bank, after 2 years, this is how much you would pay in interest. So in order to pay the bank back, you would have to give them the full $310 back plus $24.80, which would be a total
$34.80.
Yeah, $334.80 back. So that's the amount that you would owe back. All right, but they don't want that. They just want the simple interest. So there it is. All right, let's look at the next one. Same idea. The only difference is now that's days. So this is a little tricky. So let's see what we can do. So IPERT. Principal is 2,500 this time. Interest rate, what would that convert to in decimal form?
0.065.
Yeah, 0.065. Very good, because the decimal moves 2 places to the left. 1, 2. There's your 0.65. And then 90 days, remember, it has to be in years, not days. So does anyone know how to go from 90 days, how to convert 90 days into years?
So would you make it a decimal point? Like, would you be like 90 days is 3 months and that's a third of the year? So would it be like 1/3?
I think you are on the right track, yeah. So this is the way I would do it. You could do 90 days, and then we know that they're telling you that this is how many days there are in a year, right?
Yeah.
So you would do 360 days on the bottom, 1 year on the top, and then you could cancel the days out because one's on the bottom and one's on the top. So that means you can cancel out the units, and then you're left with years. So you're going to have 90 times 1 divided by 360. So 90 times 1 is 90, divided by 360 is 90. I think it's 1/4, 360. Yeah, it's 1/4, which is, you can write this in a decimal if you want, or in a fraction, 1/4 or 0.25. So I'll just stick with the decimal since we're going to multiply this out. So 1/4 is the same as 0.25. So now you have, so in other words, in order to convert days to years, all you have to do is divide by 360. So 90 divided by 360 turns out to be 0.25. And there you go. And so that's going to be our answer, whatever that turns out to be. So it's going to be $40.625. That would convert to 63, right? Because it's 625, but you have to round to the nearest cent. So that the 5 will bump up to 2, and it'll change that to a 3. Yeah, so there it is. The simple interest is $40.63. All right, let's look at this one. So same thing, I've heard again. The principal amount that we're borrowing is $1,500. The interest rate, this one's a little bit tricky, but let's see, what's 3 divided by 7 on your calculator? Do 7, I'm sorry, 7 divided by 8.
3.875.
Yeah, that is going to be 3.7, oh, I'm sorry, 3.875%, but you still have to convert this to a decimal by moving the decimal
To the left.
to the left. So it's going to be 0.03875. And then 9 months, well, if to convert days, you divide by 360, what would you divide this by?
You would, I personally would convert the months into days, which is 9 months will be, how many days? Crap, I can't think right now. I just know that 9 is 3/4 of the year, so it'd be 0.75.
By like 12?
That is right, 0.75. And so what you would want to do is, because there's 12 months in a year, all you have to do is divide by 12.
Okay.
So if you divide by 12, that's going to give you, it's going to convert the months to years, which in this case was 3/4 years, which is the same as 0.75. So it is 0.75. So all you have to do is on your calculator, do 9 divided by 12, and you'll get 0.75. All right, and so now we can work this out. 1,500 times 0.03875 times 0.75 is $43.59.
59 cents.
Yeah, 43.59. All right, there it is. All right, the last one of this type would be same old thing, right? So 587 times, don't forget to move the decimal 2 spaces. Whenever you see a percent sign, you should always move it 2 spaces to the left. So this is going to be 0.0. How many zeros after the decimal should I put?
It's 1, 2. What's that? 2, 1, 2. 1, 2. Wait.
0.00045. So 3.
Yeah, so it's 0.00045. 3 decimals. I mean 3 zeros after the decimal, and then 2 months. That means don't forget to divide by 12 because there's 12 months in a year.
So it's gonna be 0.16, but then you will round up, so it'd be 0.17, because it's 1666666. There's a whole bunch of sixes in 17.
Yeah, it's going to be 0.1666, or let's just do 1.17. You're right. Let's just round 2 decimal places is good enough. So if we do that, 0.17, that should be good enough. So let's see what that turns out to be. 587 times I'm getting very small amount, huh?
4 cents.
Wait, did we do this right? Oh, I see what the problem is. Oh man, they tricked us. I didn't even notice this until now. So let's backtrack. Remember they said over here that the time and the interest must be in the same units, time and interest. So look at the interest. It's not per year, it's per day. So I have to convert this to days. or we have to convert this to days so that it'll be in the same unit. So anybody know how many days there are in 2 months, assuming that there are
60.
60.
yeah, 30 days in a year, 30 days in a month. So that's gonna be the same thing as 60 days. And now this is the units that we need to use because this is in per day, so this has to be per days. All right, so now we can do this. 5, 8, 7. This one stays the same. 1, 2, 3, 4, 5. And now it becomes 60 days. All right, so this is the correct way to do it. I thought something was off. And now we get, and
So
if you,
you wouldn't divide 60 by 360 days?
no, because then that's gonna go back to years. That's gonna convert this to years, but because this is in per day, we have to keep it in days. So, yeah, all these are assumed to be per year, per year, per year, unless it says something different. And if it says something different, yeah. Right. So there it is. All right, now let's look at a word problem. All right, so Kevin borrows $2,200. $2,200 from his grandparents to have a corrective eye surgery. His grandparents give him 18 months to repay the loan with an annual simple interest of 7.5%. See, this is an annual interest. So that means that the time has to be in years to cover their loss of not having that money earning interest in their investment. All right, find the simple interest. So IPRT. All right, so we know the principal amount is 2,200. The interest rate, how would you write that in decimal form?
Point 0075.
Just 1, 2, so 0.075, yeah, 0.075. And then we need to convert months to years, right? So divide this by 12, because there's 12 months in a year. So 18 divided by 12 is 1.5, right? That's 1.5 years. All right, so that should do it. Let's see how much Kevin is gonna have to repay his grandparents, 2,200. I'm getting 200.
$47.50.
$47.50.
Yeah. And that's just the interest. He would still have to pay
The 2,200 on top of that.
on top of that. Exactly right. Yeah. But for this part, they just want the interest. All right. Find the amount Kevin will pay at the end of 18 months. So there we go.
$447.50.
Yeah. All right. So that's going to be 2,447. All right. And 50 cents. So 2,447.50. All right. So that's how you would apply that. All right. Now let's move on to the next one. All right. This time John borrows $240. After 1 month, he repaid the original $240 plus $48 in interest. What was the annual rate of interest? Oh, this one's interesting. Now they're asking for the interest rate. So let's still use IPERT. All right, this time, do we know what the interest is this time?
No,
Yeah, $288.
The interest is just the I.
Or $48.
oh,
Yeah,
yeah,
it's-
$48.
Yeah, it's just that. $48 is your interest.
Oh, okay.
So that's 48. The principal, how much did he borrow to begin with?
240.
40.
Yeah, that's your P. The interest rate, we don't know. And then time, how long did he?
1 month.
1 month, but don't forget, because the interest rate is an annual interest rate, that means we have to convert this to years by dividing by 12. So 1/12, I'll just put 1/12. You can convert it to a decimal if you want.
0.08.
Okay, 0.08.
0.08.
1 divided by 12 is point. Oh, because there's a 333. Let's just keep it as a fraction. So it's a little bit easier in fraction form this time because 12 goes into 240 evenly, right? So 12 goes into 240 how many times? Let's see, 240 divided by 12 is 20. 20. So now the new equation becomes 48 equals 20 times R. Anybody know how to solve for R?
You divide both sides by 20.
Yeah, divide both sides by 20. And that's going to leave us with R equals 48 divided by 20 is 2.4. All right, so that is our interest rate, 2.4. But this is a little tricky too. To convert it to a percent, anybody remember how to go from decimal to percent? What do you have to do to go from?
Move increases to the right.
So, yeah,
Yeah, move it to the right, multiply by 100, which means move it to the right, two spaces.
Oh,
So it's gonna 240%. That's a high interest rate. So that's a very high interest rate, 240% interest rate. All right, that would be a ripoff. If you see a credit card that is offering you 240% interest rate, don't get it. That's very high. All right, there is another type of loan. It's called the discount note, for which the interest is paid at the time the borrower receives the loan. Okay. The interest charged in advance is called the bank discount. So let's see what this is all about. All right, Matt took out $500 loan using 10% discount note for a period of 3 months. Determine the interest he must pay to the bank on the date he receives the loan. All right, so we're going to use the same formula for this. I equals PRT again. All right, so let's see what we know. We still know that the principal amount is 500. The discount is 10%, so that's your R. And then the period of time is 3 months, which is time, but we have to divide by 12 because we want it to be an annual. So that's going to be 3/12, which is, we can convert that. 0.25, yeah. All right, so let's find out how much this turns out to be. So it's going to be 500 times 0.10 times 0.25, and that is whoops,
12.5.
12.5, which is $12.50. All right, so that's how much he would have to pay to the bank on the date that he receives the loan. All right, let's look at this next one. It says find the net amount that he or she receives from the bank. I think Matt, I don't know. It doesn't matter. Find the net amount of money that he or she receives from the bank. So they tell you what the formula is: the original amount minus the interest charged. So the original amount was $500, right?
yeah.
487.50.
Yeah. So if you subtract the interest charged, then that's how much of money that he or she receives from the bank. It's going to be $487.50. All right. The actual rate of interest for the loan. Let's see what that is. Okay, so notice that they use the word actual. Actual rate is because you're not really going to get $500. You're going to get this amount. So this is your actual principal amount. So you're going to use IPERT. But the principal is not really 500. It's really this amount because that's how much you're actually given. And the interest rate, we actually know the interest is $12.50. And the principal is $487.50. The interest rate, we don't know. That's what we're looking for, the actual rate. And then the time, it's the same time. So it's going to be, what is it, 0.25, was it? Yeah. So first thing we should do is multiply these two numbers. Let's multiply these two together. 487.
121.88, because it comes to 121.875, so you'll round the 7 up to an 8.
Yeah, that's right. Okay, so 12.5 equals 121.88 R. All right, and then we divide both sides by the 121.88 to solve for R. All right, so 12.5 divided by, should be at 0.1025, right? Let's just round to 3 decimal places. So 0.103. If you round
Rounded.
don't forget to convert that to a percent, because the rates should always be in percent. So you multiply by 100, which moves the decimal 2 spaces to the right this time.
10.3%.
Yeah. So the actual rate for the loan was really 10.3%, even though they promote it as a 10%. But the reality is, after you subtract the interest from the original amount, the interest rate is a little bit higher. All right. Let's look at this one. Julie Jansen borrowed $3650 from her bank for 8 months. The bank discounted the loan at 7.5%. How much interest did Julie pay? How much? All right, so let's find out. So same old thing. IPERT is going to be, the principal is 3650. The interest rate is 0.075 if you convert that to a decimal. And then 8 out of 12 is, what is that? 2/3, I believe, right? We can just leave it as 8/12 if you want. So let's multiply, 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 and then divide by 12. So multiply the top numbers and then divide by the bottom number. 3650 times 0.075 times 8 divided by 12. You should get $182.50, right?
All right.
All right. How much did she receive from the bank? Well, she's not going to get the full 3650, right? They're going to subtract this amount. So it's basically like she's paying for the interest up front instead of at the end. So she's just paying for it up front. All right, so here it is. So you're just going to subtract.
$467.50.
Thanks.
Yeah. All right, so if you do get 3, 4, 6, 7, and 50 cents. All right, so she's not really getting the full 3650. She's only getting that amount. What was the actual rate that she paid for? So now we have to do the IPERT again. When you see that word actual, that just means that it's really going to be higher than that. All right, so let's see what it is. We already know the interest. The interest was 182.50 cents. The principal was really 3,467.50 cents. The interest rate is what we're looking for, and then the time was 8 out of 12. So let's first multiply these two numbers and then divide by 12. So 3,467.5 times 8 divided by 12 is I'm getting 2311 point, I'm gonna round that to 67. And then you have the R. So now you just divide both sides by this number, right? So divide 2311.67, 2311.67. And that's gonna do it. R equals whatever you get. .0789. Anybody get that?
Yeah, that's
Yeah.
All right. Multiply by 100 to convert that to a percent. You get
7.9%.
7.9, or you can say 7.89.
Eight,
Either one's fine.
Oh, you went too past there. Okay.
All right. So now that does it for that. I don't know if is there more? Let's see if there's more. Oh, wow. There is more. All right. Partial payment. What is that? Partial payment. United States rule, bankers rule. Yeah, usually I don't cover this actually. So don't worry about this. We're not going to cover this. So you can just not worry about that. So we are done. That is that. Yeah, let's take a 10-minute break. Simple interest, this is called compound interest, which is more common. Usually banks are not going to just charge you interest at the end of the loan. They'll charge you, they'll compound the interest every month or every day or every year. So that's what they mean by compound interest. So here's a little warm-up exercise. It says Bill invests $1,000 at 6% simple interest. So see the word simple. So that means the IPERT annually for 1 year. How much money does he have in his account at the end of the year? So let's find out. So because of the word simple, that means IPERT. So we have the principal amount times the interest rate, 0.06, times the time, which is 1 year. So if you multiply that out, you're going to get $60, right?
Mhm.
So that'll be $60 interest. But they're asking how much money does he have in his account at the end of the year. So he's going to have the original amount that he invested plus the $60 of interest. So that's going to be $1,060. That's how much he has in his account. This is an investment problem. All right, so that's the answer. So now they say Bill invests the money he had in the account at the end of the first year at 6% simple interest annual for 1 more year. How much money does he have in the account at the end of the second year? So now he's going to do the same thing over again for another additional year.
So that'd be 2,120 without even doing all that, because you just double it.
Not quite. That's where the
Not quite.
compound, because now the new principal has changed. It's increased. So that's going to make it a little bit more than doubling. So that's your new principal. And now your interest rate is still 6%. And now you're still doing it for 1 more year. So that's still, it's 1 because it's an additional year. So now you're going to get slightly higher than 1,120 you're going to get. You get $63. Whoops. And 60 cents. So now if you add that to the original amount or the new amount, the new principal amount, you're going to get 63.60. You should get the amount is going to now be $1,123.60. So that's what compounding interest does. It doesn't just double the simple interest. It takes into account the new principal amount, and then it does a calculation on that. And so it gives you a little bit more money that way. So that's what the formula is going to do. So the formula looks a little bit complicated. Here it is. it's gonna be A equals P times 1 plus R over N to the N times T power. So this is a formula. That way you don't have to do this. See how here we had to do two separate formulas, the formula 2 separate times and then add them up.
Yeah.
Here, you don't have to do it 2 separate times. All you have to do it is 1 time. Because what if this would have said for 4 years, then you would have had to do this 4 times. That's a lot of times to do it. But if it doesn't matter how many years they say, you only have to do it 1 time with this complicated formula.
Okay.
So A represents the amount, accumulated amount. So we'll just say accumulated amount. P is the same thing as before, principal amount. R is still the same, interest rate. N is the number of times, number of compoundings per year. So sometimes they'll say quarterly. Quarter means 4 times a year. Sometimes they'll say monthly. Monthly means 12 times a year. Sometimes they'll say daily. So that'll be 360 times a year. T is the number of years, or time in years. All right, so let's go over this. Here's what the N means. It says a period, the number of times that the interest is compounded per year. So if they say daily, we're supposed to assume that there's 360 days in a year. So N would be 360. All right, 360. If they say weekly, there are 52 weeks in a year. If they say monthly, there's 12 months in a year.
Why
Those-
360 and not 365 for days?
Yeah,
Yeah.
that's true. I don't know why they make that assumption, because they made that assumption in the previous section, so I'm just gonna stick to their assumption, but you're right. I don't know why they call that 360. We'll just go with it though. Quarterly, there's 4 quarters in 1 year. Semi-annually, that means 2 times in 1 year. Semi, that means half or twice a year. And annually, that just means once a year. All right, so those are the numbers you're supposed to use for N. Whenever you see these keywords, that's what your N is. All right, so now let's try it. Kathy invested $5,600 in a savings account with interest rate of 7.5 compounded monthly. So there's the keyword. Monthly, that means N equals, anybody know what N would be?
12?
12.
12, yeah. All right. Determine the amount after 10 years. That's your T. This is your P. This is your R. But remember, convert that to a decimal. All right, so now let's plug it into our formula. A equals P 1 plus R over N, all to the N times T exponent. So let's plug it in. So let's see. P is 5600. R is 0.075. N is 12. All of that raised to the 12 times 10. So this is where you have to use your calculators to plug all this into your calculator. So let's do this. Let me show you how I would plug it into my calculator. All right, so clear. And let me share my screen. So let's do that. So 5,600, open parentheses, 1 plus R 0.075.
Where was the R?
The R is the interest rate. Remember, it was 7.5%. So we converted that to 0.075. And then divided by N, which is 12. So I use the division for the fraction bar. and then close parentheses. And then the exponent button, depending on where your calculator looks like. For me, it's this one, this little arrow that points up is the exponent button. Depending on your calculator, some of you might have a different calculator that might be like y to the x power. So this for me is a exponent button, and then over here you want to do 12 times 10, but it might be a good idea, depending on your calculator, to put parentheses around the exponent. So parentheses 12 times 10, close parentheses, just so that your calculator knows that the 12 and the 10 has to be inside the exponent. Some calculators, if you don't put the exponent, only the 12 will be up there, but the 10 will be on the bottom. So you don't want that. All right, enter, and you should get that much money, $11,827.56. So that is the final answer. So 11,827 and 56 cents. All right, so that was a good investment. They started off with $5,600, and after 10 years, with the interest rate of 7.5% compounded monthly, they ended up with $11,827. So I think that's more than double. 56,000 times or 100. It's like, yeah, a little bit more than double. So that's pretty good. So that is it. So hopefully you guys are getting the same thing on your calculators. All right. So now we can answer this question. Compute the interest earned. So the interest that you earn, anybody know how to find the interest? If you have the principal and the final amount accumulated. Well, you would just subtract. That's how much the interest you would earn. So it's going to be 11,827 minus the amount that you invested to begin with. That's how much interest you earn. So let's see how much that is.
$6,227.56.
Yeah, that is it. So that's a lot of interest. But it is a long time, 10 years. But
Yeah.
that's still pretty good though. All right, let's look at the next one. So that's why this formula is helpful. Otherwise, you would have had to do this
Yeah.
simple interest formula a lot of times. You would have had to do it 12 times for every year, and there's 10 years. So 12 times 10, you would have had to do this 120 times and then add it 120 times. So instead, you only have to do it one time in this nice formula. All right, Kathy invested that much. That's our P. Our interest rate semi-annually. Anybody know what N has to be for semi?
2.
Yeah, 2. And then the number of years is 3 this time. So our formula. All right, so let's plug in the numbers. P is 650. R is 0.08. N is 2. And don't forget to close the parentheses, raised to the exponent of 2 times 3. If you want, you can do this math in your head, so it's easier to type into the calculator. You can just call that 6 if you want. So go ahead and type that into your calculators the way we did it before. And let me know what you get once you get an answer. Anybody get an answer yet?
No, I think I messed up.
I'm getting $822, and if I round to 2 decimal places, I'm getting 46 cents. So see if you guys can get that on your calculators. This amount should be 457, but I just rounded that to 46 cents. And then for the interest earned, remember, you're gonna do the amount that has been accumulated minus the principal that was invested to begin with. So that would be $822.46 minus $650. For that, I'm
Point
Go ahead.
46.
yeah, $172.46, right?
Yeah.
Yeah, that's how much interest you accumulated. And that's because it was only 3 years, and yeah, and you only compounded semi-annually instead of monthly. So the more times that you compound the interest, the higher the more times that you compound per year, the higher your interest will be. So this one was higher than this because of two reasons. You compounded more times per year, and also because it was invested for longer. 10 years versus 3 years is longer. All right, let's look at this one. Gene Woody invested $6,000 at 8% compounded quarterly. So what would quarterly be?
It would be 4.
Yeah, n equals 4. 3 years later, she withdrew the full amount and used it for the down payment on the house. How much money did she put down on the house? So that means that T is 3 because it took her 3 years. The investment was for 3 years. So we have everything we need now. A equals P 1 plus R over N to the N times T power. P is $6,000. R is 0.08. N is 4. N times T is 4 times 3, which is 12. So if you want, you can just call that 12 instead of 4 times 3. So plug that into your calculators and let's see how much she put down for her down payment. Let me know if you guys get an answer.
You have to put a close parentheses with the exponent.
Close parentheses, yeah, here and here.
Yeah.
Yeah, depending on the calculator, just to be on the safe side, I would recommend that you do put parentheses there, just to be on the safe side. All right, anybody get $7,609? Oops. And 45 cents. That's what I'm getting. That's how much she, that's how much interest, or that's how much the total amount that her investment became. It went from $6,000 to $7,609 after 3 years. And that's how much she put down on the house that she wants to buy. All right, Tom Angelo needs to borrow $1,500 to expand his farm, implement maintenance business. He learns that the local bank will lend him the money for 2 years. So he needs to borrow $1,500, that's P. 2 years, that's your T. Interest rate of 10%, that's your R. Compounded quarterly, what is N?
Quarterly. You said quarterly?
Yeah,
4.
4. All right, after hearing of this rate, Tom's grandfather offers to lend him the money for 2 years with simple interest rate of 7%, so simple interest. So now that's a different type of interest. Okay, how much money will Tom save by borrowing the money from his grandfather? So it looks like his grandfather's gonna give him a better deal compared to the bank. So let's figure out, there's gonna be we have to do two problems, the bank and the grandfather. Let's do the bank first. So the bank is going to be A equals P 1 plus R over N times T. All right, so that's 1,500. 1 plus the interest rate that the bank is offering is 10%, so 0.10. And N is 4 quarterly. 4 times 2 years, so that's 8. All right, so let's find out what that turns out to be first. That's how much the bank is going to, that's how much he's going to owe the bank back after 2 years. I'm getting 1827 and 60 cents. That's how much the bank is gonna, that's how much you would owe the bank back after 2 years. So he's paying about $300 in interest, right? Or 327, because if you subtract, that's how you get the interest. All right, let's see what kind of deal the grandfather's going to give him. So because it says simple interest, remember simple interest is IPERT. So the interest is going to equal the principal amount that he borrows, 1,500, times the interest rate. His interest rate is lower, 7%, 0.07, and the time is still 2 years. So let's see what that turns out to be. So he's only charging them $210 of interest. And how much did we say this interest was going to turn out to be? If you subtract the final amount minus the principal amount that he borrowed, that's going to give you the interest. So subtracting, I get $327.60. So the question is, how much will he save? So anybody know how to find out how much he's going to save by going with the grandfather as opposed to the bank? Well, you would just subtract the two interests. So if you subtract them, that's going to tell you how much he saves. Tom will save, what is that? 327 minus 210, $117.60 savings. So not that much of a savings, but hey, anything is good, right? Any type of savings is good. All right, so that's how you would work out a problem like that. So there's a lot of things going on here. First, you had to find out how much the bank was going to charge them, then the grandfather using a different formula because it said simple. Then you had to subtract the two interests to figure out how much savings he would get. All right, let's move on to number 5. It says here. All right, it says, well, first of all, they want to know how to find present value. So there is a formula for that, present value. So let me give you the formula, then we can talk about it after. So here's the formula for present value. All right, so it's going to be P equals A over 1 plus R over M to the NT power. So it's basically the same exact formula, except you're solving for a P. So if you take that formula and you divide both sides by all of this, you're going to get P equals A over 1 plus r over n to the nt. So it's the same exact formula, you're just solving for p. All right, so so that tells you like the present value of something given these other the other information. So let's see how that would look like. So Ryan will need 30,000 in 6 years. So that's kind of projecting how much the person would need in the future in order to know how much he should invest now. So he's going to need $30,000 in 6 years. How much should he invest in a CD that has a rate of that compounded quarterly? So this is a situation where you would now use this formula because you're trying to figure out how much he should invest now, knowing how much he needs in the future. So this is your A this time. This is going to be your A. That's how much you need in the future. This is how many years you need. This is the interest rate. Compounded quarterly is N is 4. All right, so we know A is 30,000. That's how much he needs in 6 years. 1 plus R, the interest rate is 0.0472. The N is 4 quarterly, raised to the 4 times T, which is 4 times 6, which is 24. So you can just put 24 here if you want, or you can put 4 times 6. Just remember to put parentheses around 4 times 6 on certain calculators. All right, so let's figure out what that looks like. Well, 30,000 divided by parentheses 1 plus 0.0472 divided by 4, close parentheses, exponent, parentheses 4 times 6, or you can just type in 24. And that tells you how much money he should invest now. So this person should invest, according to my calculator, $22,638.57. All right, so that tells you that you need about maybe like almost 8,000 in growth. So if you invest this much, in 6 years later, it'll become 30,000. It's kind of a way to project how much you would need to invest now in order to gain a certain amount of money that you need. All right, how much money should parents invest at the birth of their child to provide their child with $50,000 at the age of 18? So this is kind of a smart way to, if you have children, you want to put some money for a college fund or something, so that 18 years later, you have enough money for them to go to college. So let's see how much money they would have to put in now in order to have this much 18 years later. So this is A, this is T, this is R. Quarterly means 4. So we use the same formula. So you want to have $50,000. Interest rate is going to be 0.08. N is 4. And then 4 to the 4 times 18 is the exponent. So let's see what this turns out to be. All right, I'm getting a grand total of $12,000 and $12,015 and 94 cents if you round up. So this tells you how much you would want to invest now, so that 18 years later, your child would have $50,000 to go to college. All right. I think there's one more problem. Let me see. Yeah, we're not gonna do these. You're not gonna be responsible for this page. So we're just gonna do the final problem. So here it is. The village of Kyler recently completed the construction of a new water tower. The entire cost of the water tower was $925,000. The state paid $370,000 of the total cost through awarding of a grant. In addition, the village can delay paying the balance of the cost for 30 years without paying any interest during the 30 years. To finance the balance, the village board will at this time assess its 598 homeowners a one-time flat fee surcharge and then invest this money in a 30-year CD paying 7.5% interest compounded monthly. What does the balance do on the water tower? Wow, this is a lot of words. So let's see if we can make sense of this. All right, it looks like, what is the balance on the water tower? All right, so the entire cost of the water tower is this much, right?
Yeah.
And the state is paying this much. So what is the balance? So we just have to subtract is what we have to do here for now, just for the first part of the question. That's how you find the balance due, because the cost minus what the state's gonna pay. Let's figure out what that is. Getting 55,555,000. So that's the balance that's going to be owed. All right, how much will the village of Kyler need to invest at this time in the CD to raise the balance due in 30 years? So now we need to know that they need to raise this amount in 30 years. So this is your A, this is your T. All right, so let's plug it into the formula. All right, so the amount is 555,000. It says compounded monthly, right? So that is, anybody know what N is?
Yeah, 12.
12, yeah. So R is 0.075. It tells you the interest rate here. Divided by 12 to the 12 times 30 years. So that's going to be 360, right? 12 times 30 is 360. So you can write 360 here if you want, or you can just put parentheses around these numbers. So let's type that in. All right, I am getting a grand total of 58,907.61 if you round. All right, what amount should each homeowner pay as surcharge? All right, so we have to know how many homeowners there are so that we can divide that evenly in order to get each individual's surcharge. So how many members are there? Let's see. 598, right? Homeowners. So you're going to divide the amount that needs to be invested by the number of homeowners, 598, and that'll tell you how much each person should pay. So each person's going to only have to pay $98.51. Wow, so that's not so bad. I thought it was going to be a lot more. So this is doable. It's kind of like, consider it like a tax so that this city or this village will have a new water tower. You only have to pay $98.51. All right. That is it. Wow, right on time, perfect timing. So let me stop recording and let me just take roll.